data or summarizing data. It provides an overview of the attributes of a data set. We have two types of measures to describe the data. What are they? Central tendency measures and dispersion measures. Central tendency measures are the averages. Which are the main averages? Three averages: mean, median, and mode. And we have two important dispersion measures: semi-interquartile range and standard deviation. This mean and standard deviation together seen in many articles. And at the same time, you can see semi-interquartile range and median uh, together in certain publications. What is the reason? Uh, as we said, we have three averages: mean, median, and mode. Even though there are three, the selection of this average, selection of one among these three depends on the normality of data. If your data is normally distributed, mean and standard deviation are the better measures to describe the data. That is why these two appear together in journals. And if your data does not follow normal distribution, semi-interquartile range and median are used to explain the results. And we have other types of statistics known as inferential statistics. Here we'll be taking or making some inferences from the sample, and the results will be generalized to the entire population. And we have a lot of statistical tests available and that are used for making the inferences from the sample in inferential statistics. And the selection of descriptive statistics and inferential statistics, that is our problem. Descriptive statistics are mainly used in descriptive studies or also used in lower level analytical studies like cross-sectional study, the prevalence studies. If you want to study the prevalence of a disease, usually prevalence is measured in or expressed in percentages, and we may have some other study variables related to the prevalence, and that kind of variables, if the variables are quantitative type, you'll be expressing these variables using mean and standard deviation. Sometimes it may be using median and semi-interquartile range. Actually, these descriptive statistics are enough in descriptive or cross-sectional studies. But if you are planning a more advanced studies like a case control study or a comparative cross-sectional study, some in-depth analysis techniques are necessary, and we need some statistical test also. Now moving to such kind of test. Before that, it is showing the step-by-step procedure used in testing. We'll have a defined population and sample that we told yesterday, and data will be collected from the sample, and it will be analyzed, make the inference, and the results can be generalized to the population. This is the step-by-step procedure used in testing theory. It is basic theory behind the statistical test, but we do not bother about these theories and all, because you will be doing analysis with the help of software. And the two classification of tests, what are they? Parametric tests and non-parametric tests. The selection depends upon the normality of data. Parametric tests are usually applied for normal data, and non-parametric tests are used for non-normal data. The test is an important large sample test used to test the significance of mean, or can be used to compare two means if your population is normal. Students t-test is a small sample test. When you say that a sample is small or large, 30 is the cutoff value. If you have 30 observations, you can say that your sample is large. Otherwise, we have to apply some or select some small sample test, and one of the important small sample tests is students t-test. We have two types of students t-test: unpaired t-test and paired t-test. Both are applied for testing the statistical significance of difference between two averages, two means. An unpaired t-test is applied for independent samples, and a paired t-test can be applied for uh, dependent samples. That is, if your study is case control one, unpaired t-test can be applied. And if you are planning an interventional study, you'll be having some dependent data, either pre intervention data and post intervention data, pre or post data, or some we can see some data in research, like in the field of anesthesia. They'll be having some data like that, dependent samples. And ANOVA is the extension of unpaired t-test. Here, number of sets will be at least 3. That is why it's called the extension of unpaired t-test. And in unpaired t-test, we'll have at most 2 sets, 2 groups. And that will be a comparative study. And ANOVA is the extension of unpaired t-test. And Pearson's coefficient of correlation is used to establish the relationship between two quantitative data. It is not a statistical test, it's a technique. And we have other non-parametric tests. Here, Mann-Whitney test is the non-parametric version of unpaired t-test, and Wilcoxon sign rank test can be applied for a paired t-test. Can be used for non-normal data. If your data is dependent, it's a non-parametric version of paired t-test. And Kruskal-Wallis test is the non-parametric test corresponding to ANOVA. You will have more than 2 groups. And Spearman's rank correlation is widely used in reliability analysis, and it is the non-parametric version of Pearson's coefficient of correlation. It is if your data size is too less, or whenever you handle some ranks instead of ratio level measurements, Spearman's rank correlation coefficient is the most appropriate. So the selection of the technique depends on normality of data, and it depends on the nature of data. We have 2 types of data: quantitative data and qualitative data. That depends on your objective. What you want to study. You want to compare to parametric to quantitative values or qualitative values. Sometimes it may be a comparison between averages, or sometimes it may be a comparison between 2 proportions. For that, the test selection depends on the nature of data, and sample size is another factor. We have 2 types of tests available: large sample test and small sample set. Check the data size and select the appropriate one. It's the shape of a normal curve. It's a bell-shaped curve, symmetrical about mean. Mean is mean equal to median equal to mode for a normally distributed data. This normal distribution is one important sampling distribution. It is the basis of testing of hypothesis theory. That is why I showed you. Okay, then whenever you check the normality, you should get a curve like this. You should get a normal curve, bell-shaped symmetrical curve. And we have different approaches to test the normality of data. One is a graphic approach. It is possible to draw a QQ plot with the help of SPSS software. Otherwise, we have 2 important statistical tests available: Kolmogorov test or Shapiro test. Do the analysis in SPSS and check your data whether it follows normal distribution or not, and in-depth analysis can be done based on that. The selection of the test and all, everything depends upon the normality. And yesterday we had seen 2 types of errors, type 1 error and type 2 error. It is closely related to the statistical test. That is why I put this slide. Two terms we use for the sample size calculation, also for the analysis. Here, table describes two states. Here, null hypothesis defined as true and false on left side, and the condition, the result, what you obtain from the sample. If the null hypothesis is true, it should be accepted, but the sample does not giving an evidence to accept it, then the H0 will be rejecting, and the type 1 error occurs. And we have other situation where the null hypothesis is actually false, and if H0 is false, it should be rejected. But we may have to accept the null hypothesis, and then type 2 error occurs, and alpha, the significance level, is the probability of type 1 error, and beta, the probability of type 2 error, and 1 minus beta. What will be the 1 minus beta? 1 minus beta, the complement event of type 2 error. That is the probability of the exact decision. This probability of accepting H0 when H0 is true. It is called the power of the test, the probability of correct decision. It is the ability of the test to accept the correct result. Yesterday I had seen that the desired power level fixed as 80% and significance level fixed as 5%. For an explanation, I'll show you one more slide regarding the type 1 error and type 2 error. It's a common example. Here we fix the null hypothesis in two different ways. For an explanation, in the first case, H0 is true. That is, the defendant is innocent. Here, the accused is innocent but punished. The H0 is reject H0 when H0 is true. That is why type 1 error occurs. Then in the second case, we assume that H0 is false. What does it mean? The accused is guilty but not rejected. He gets released. Not rejected means accept. The defendant is innocent. It's usually it's a common example. Here, in both cases, they have no appropriate evidence to prove the exact result. That is why two types of errors happen. In our case, in our situation, the same thing. If the samples do not provide the adequate information, then the result will be what happens. The result will be in opposite direction. Here, there is the importance of sample size and all. That's why it's the one reason behind the fixation of sample size. Our sample size should be adequate as possible. Otherwise, we may not get the desired result. And p-value, it is the smallest level of significance at which the null hypothesis would be rejected when a specific test procedure is used on a given data set. Here, I told you that all analysis will be done with the help of softwares, and you will get a p-value from softwares. And you have to make a decision. What is the decision? Just bother about the decision only. We'll have a p-value there. Compare it with the significance level. The conventional value of significance level is 5%. 5% is the permissible error. What is alpha? Alpha is the probability of type 1 error or significance level. It is prefixed before start of the study. You have to input that value in your computer, in software. The traditional value of alpha is 5%. The probability of chance variation by chance occurrence is 5%. Otherwise, 95% we are confident that everything done accurately. We have got the exact samples without any variation like that. So compare this significance level with p-value. P-value will get from the software. If your p-value is less than or equal to the significance level, you have to reject it. Then the test will be significant. P-value is actually, it is a practical value, and alpha can be considered as theoretical value. Both are same. This is the probability or chance variation. It's a kind of error. And if your error level is very less compared to the fixed level, you will get a significant result. That's the essence behind it. And another term, confidence interval, used in descriptive studies. Very important one. It predicts the variation exists in the population value, how much variation is possible. Or by 95% confidence interval, we mean that we are 95% confident that our value obtained is within this interval. The mean minus 1.96 into standard error to mean plus 1.96 into standard error. If you are calculating an average value, it is the formula of 95% confidence interval of mean average. And we have different types of confidence intervals that depends on the parameter. We have confidence intervals of mean, difference in means, proportion, difference in proportions, and like that. So the statistical test depends upon your study objective or hypothesis. Depends on the choice depends on the normality of data and nature of data, quantitative or qualitative type, and your sample size also, a small sample or a large sample classification, and also depends upon the number of groups. It's a single group, or whether it is a by weight two group study or a multi-group. And we have other two techniques named correlation and regression. Correlation, we already discussed. It is mainly used to establish or to describe the relationship between two quantitative variables. Here the condition is that both variables should be quantitative by nature. And you have already seen that there are two types of correlation: Pearson's correlation and Spearman's rank correlation coefficient. Its value lies between -1 and +1. If you are getting a value R is equal to 0, you can say that there is no linear relationship between variables, and it should be nearer to 1. Then you will get a significant result. And we have other technique known as regression. Regression is used for prediction of certain variables using a set of independent variables. We have different types of regression techniques: simple regression technique or multiple regression technique, and other classifications: linear or logistic regression. See one regression model. Y is equal to a model. Hello?
Rajni ma'am, can you please go back 2 slides? There was somebody who wanted to see that slide again. 16 slide. Yeah, the one before this. Yeah, I think this one. Abhijit, is it this one?
Any description needed?
I think he wanted to see
Any
this
query?
slide again. Yeah, he wanted just some explanation on this slide.
What is the query?
No, there's no query as such. He just wanted to see the slide once more. So just Kanchamadi.
Showing the 16th slide.
Yeah, this one. Yeah.
Is it?
Yeah, this one, ma'am.
Any clarification needed?
Abhijit, if you have any doubts, you can ask. No, ma'am. Okay, there's no doubts, ma'am. I think you can move. Next slide. Maybe he just wanted to see.
Shall we move?
Yes. Proceed. Proceed, ma'am.
For an explanation, we have taken one regression model. Here, the model is y is equal to a plus. Don't bother about a, b, x1, x2. Anyway, this x1, x2, x3 are the independent variables and y is the dependent variable. And I'll tell the classification of regression techniques. See two examples. Prediction of height from foot length. Here, height is the dependent variable y and foot length is the independent variable x1. There is only one independent variable, foot length. Here, we deal only two variables. So it is the case of simple regression. Okay. Then the second example, identify the risk factors of myopia. Myopia status, yes or no. It is the dependent variable. And there may be a lot of risk factors or factors associated with the myopia. So we may have x1, x2, x3 and all. This is the multiple regression scenario. And we have two other classification, linear and logistic. See the first example, prediction of height from foot length. Here height is a quantitative variable. So linear regression technique should be applied. And the second case, myopia status is the dependent variable. It is categorical by nature. Myopia present or absent. So y is categorical and logistic regression can be applied. That's all. Clear. And we have another technique, survival analysis. It is usually used to explain the survival experience of a set of study subject, mainly used in what we call radiotherapy, cancer research. Kaplan-Meier plot, log rank test, and Cox proportional regression technique. The common methods used in survival analysis. A lot of methods available, and all these three, Kaplan-Meier plot, log rank test, or Cox proportional regression techniques are available in SPSS software. Not only in SPSS, it's available in R, EpiInfo. You can make use of that. Then one example of survival. Here two types of drugs are compared. Here the independent variable will be the time to survive. It's a peculiarity of survival data. Actually, the dependent variable will be quantitative or a qualitative variable. Here the dependent variable is the time. And we have other sets called sensitivity, specificity, positive predictive value, negative predictive value, ROC curve, kappa statistics. They all are used in diagnostic test evaluation studies to detect the malignancy and or to differentiate malignancy and benign, or to like it's common. And kappa statistic is used in reliability. ROC curve is to find out the cutoff value of a particular tool. The tool may be a new one and maybe comparing with the standard one. It's a nutshell of all statistical tests. Already discussed, simple sample mean is a test or t-test can be applied. The corresponding non-parametric is sign test. Difference of two means, the samples may be independent, then unpaired t-test is the suitable one, and the non-parametric version is man with new test. Difference of two means, if you are handling dependent data, paired t-test is the appropriate one, and the non-parametric version is Wilcoxon's matched pairs test. Difference of more than two means, independent samples, ANOVA is good, and the corresponding non-parametric test is Kruskal-Wallis, and you just trying to find out the relationship of two quantitative data, linear correlation or Spearman's rank correlation. And if your data is qualitative by nature, the most popular non-parametric test is chi-square test, and it's a test can also be applied. See some data. Here both data are qualitative, both variables are qualitative by nature, poverty and birth weight, qualitative manner. Even though the birth rate is quantitative, classified as a qualitative, normal and abnormal birth weights given, and chi-square test can be applied. Here you can see two sets of data, quantitative data, but the sample size is too less. We are comparing the averages, independent data set. So unpaired t-test is the suitable technique. And here we'll be dealing with more than 3 groups, like 4 groups given quantitative data. So ANOVA is appropriate here. And about the analysis plan. These two sentences are commonly in our protocol while evaluating. That is why I put this slide. I'll read out the sentences. All quantitative data will be expressed in mean and standard deviation. Qualitative data will be expressed in percentages. And appropriate statistical techniques will be considered for analysis of data. This is the vague idea about the analysis plan, and everybody can write this kind of sentences, but you can modify it a little bit. Modifications can be there. I'll show you another slide. It is the study of prevalence and risk factors for depression among community resident older people in Kerala. This type of sentences we are expecting. The first sentence, the data will be analyzed using EpiInfo software version 7. That is, which is the what we call, which is the software you have applied or you will be applying for the analysis of data. It can be EpiInfo, SPSS, or anything. Demographic data profile will be explained with the mean standard deviation and other descriptive measures. You may have some demographic data or clinical data and non-clinical data. First of all, we'll explain the demographic profile of study subjects. That is why I put this sentence. A demographic profile will be explained with mean standard deviation. And here the study, the first objective is to find out the prevalence of depression. So that clarified here, prevalence of depression will be reported in percentage with 95% confidence interval. Prevalence in percentage and its variability range explained in 95 using 95% confidence interval. And the secondary objective was to identify the risk factors. To identify the risk factors associated with the depression, bivariate analysis is necessary. So the fourth sentence, the associated factors of depression will be identified by doing chi-square testing, bivariate analysis, and odds ratio will be found out. Then the multivariate analysis technique. It's a logistic regression technique applied to find out the risk factors. This kind of sentences we are expecting. Just the last slide regarding analysis plan. Some kind of variations will be there because you don't know exactly or exact picture about the nature of data, means whether the data is normal or non-normal, like that. You may get some information from certain literatures, and you just go through that and make an idea about the analysis plan. And it may not be a completed one, but some kind of modifications are necessary from this type of things. That is why I described this slide. It's all about the statistical things related to your protocol. So plan well, complete the protocol, and submit it as soon as possible. You can take help from others, maybe from your guides, other faculties, or faculties from community medicine, or IRC persons can give the guidance. Okay, maximum utilize the faculties and do it well as possible. Thank you.